Here I will be covering low pass and band pass filters with ultra broad stop band bandwidth based on directional couplers. Here I will be briefly covering the extended stop band LPF principle, the generalized branch line hybrid ring based transverse filtering section, and branch line hybrid based transverse filtering section. This is the extended stop band LPF principle. Here we can see the TFS1, TFS2, TFS3 up to TFSN in upper figure. They combine at different frequencies, say FD1, FD2 and FDN, and multi-TFS cascade. So the final result becomes a LPF with an extended stop band. So we are going to achieve extended stop band in an LPF. The diagram of generalized branch line hybrid. Here port 1 is input, and port 2 is output. Depending on input signal path, process is split into several components propagating through different signal paths. Thus, we get the total filtering action, whether the signal forms constructive or destructive interference at the port. The modified branch line hybrid based transverse filtering section. The lines are with lambda by 2, but Z1 and Z2 are to finally adjust the electrical parameters of the circuit. Further convert this LPF into BPF, we need another section, grounded section. This is modification of generalized hybrid ring to hybrid ring based transverse filtering section, and diagram 2 shows the band pass version of it. Practical calculation. For hybrid ring based transverse filtering section, solving equation 1 and 2, we get zeros at FZ13 that are symmetrical above FZ2, which is at desired frequency FD. Similarly, for branch line based transverse filtering section, by solving equation 5, we get two symmetric FD at given by equation 6. Extended stop band principle, where how different TFS can be shown with overlapping responses to form an extended stop band LPF. The principle of this video. The band problem example. Here we have to create design for bandwidth of at least 500 MHz, centered around 3 GHz, and material used is Rogers 4835 with 20 mm thickness of substrate. For micro strip width calculation, we have used this equation to find out the widths of different impedance lines in shown structure. Then outputs were taken. These are the schematic unit cells shown for branch line hybrid TFS, which is used to form a band pass filter, and branch line hybrid TFS, which is cascaded to form an ultra stop band LPF. For LPF, layout of band pass filter obtained after optimization around the center frequency. The waveform for S11 and S12 parameter obtained for LPF after simulation and optimization, which shows the bandwidth of 876.2 MHz. Response for band pass filter shown S11 and S21 parameter. As shown, we have obtained the bandwidth of 0.93 GHz, which is quite near to our requirement, 3 GHz. Thank you.